Okay, so today we're going to be starting a topic called half-angle identities. It's the second half of section 5.5. We will be having a quiz on Thursday this week because we don't have school on Friday. So let's get started. Today is April 6th, and we're going to be doing the second half of section 5.5. It's called half-angle identities. Call this day 1. We're going to be spending 3 days on this. So if you look at your formula sheet, this is the bottom half. You could see that the sine of an angle divided by 2 is equal to plus or minus, depending on where the angle is. We'll talk about that more in a little bit, of 1 minus the cosine of x divided by 2. The cosine of an angle divided by 2 could be plus or minus, depending on where the angle is. 1 plus cosine divided by 2. And then we could derive where tangent of x over 2 comes from. It's a combination of sine and cosine. The formula for this would be, let's see, it would be plus or minus the square root of 1 minus the cosine of x over 1 plus cosine of x. And we could actually rationalize this and then conjugate it. So there's actually 3 formulas for this, and they're all on your formula sheet. I don't expect you to memorize these, just look at your formula sheet. Formula 1 is right here. Formula 2 would be 1 minus the cosine of x divided by the sine of x. And then the third formula, and these come from using a Pythagorean identity, would be sine of x divided by 1 plus the cosine of x. So let's take a look at some problems. What if I asked you to use the triangle? I'll draw you one. Oh, looks like my OneNote froze. I'll give it a few seconds to recover. All right. So it looks like it came back here. So, all right, so use the triangle, I'll draw this in a second, to find the exact value of the following trig functions. Okay, so the triangle that I'll give you is very, very simple. It's a right triangle. We'll put our angle right here, angle theta. This side is 3, this side is 4. And I'll ask you to find start off first by finding the sine of theta over 2. Now, we don't have to worry about a plus or minus here because I'm showing you the actual triangle, so it looks like all the sides would be positive. In the next example, we'll take a look at how to determine if it's positive or negative, but for this, the sine of theta divided by 2 would be a positive answer, and the formula we're going to be using is 1 minus the cosine of theta divided by 2. So this would be 1 minus the cosine of theta is 3/5. And then we do have to rationalize this. And the way that we could do this, 1 is the same thing as 5 over 5 minus 3 over 5 is 2 over 5. So we have 2 over 5 divided by 2 or 2 over 5 times 1/2, which is the square root of 1 over the square root of 5, and rationalizing by multiplying by the square root of 5 on top and bottom, we get the square root of 5 over 5. That would be what the sine of theta over 2 is. Now, let's try to figure out, and by the way, this, in case you missed it here, this top 5 over 5 minus 3 over 5 is 2 over 5, and we're dividing by 2. So from that step, I got here, just so we're all on the same page. 2 over 5 divided by 2 is times 1/2. Second thing I'd like us to find is the tangent of theta over 2. And we have 3 formulas we could choose from. It doesn't matter which one you use. So I'm just looking at my formula sheet, and I saw this one first, 1 minus the cosine of theta divided by the sine of theta. We could have used any of them. As long as we rationalize, we'll get the same answer. Rationalize means we get rid of the radical in the denominator. So this would be 1 minus 3/5 divided by the sine, which is 4/5. 1 minus 3 over 5 is 2 over 5. And we're dividing by 4/5, so that's the same thing as multiplying by the reciprocal. And that's why the answer for this would be 1/2. And one more example here. What if I asked you to find the secant of theta over 2? Well, the way that we're going to do this is we're going to find the cosine of theta over 2, and we'll just take the reciprocal of it. So let me show you what I mean. First, let's find the cosine of theta over 2, and the formula says it's going to be the square root of 1 plus the cosine divided by 2. Well, 1 plus the cosine looks like this. 1 plus 3/5 is 5/5 plus 3/5 is 8/5. We're dividing by 2, so I could either write dividing by 2 here, or I'm just going to multiply by the conjugate. This gives us the square root of 8 divided by 10, or 4/5, which is 2 over the square root of 5. Now that's what the cosine is. We don't have to rationalize this because we want to get the secant of theta over 2, which means we take the cosine and we just flip it upside down, take the reciprocal, and that would be the answer. If we wanted to find the cosecant, we would do the same thing with sine, and cotangent would be the same thing with tangent. All right, how about this one? Let's use a half angle identity to find the exact value for sine of 165, cosine of 165, and the tangent of 165. Okay, so the sine of 165 using half angle identity would really be the sine of 330 divided by 2. Cosine of 165 was really the cosine of 330 divided by 2. And the tangent would really be the tangent of 330 divided by 2. All right, so let me just check something real quick here. Okay, so now let's figure out if they're going to be a positive or a negative. The sine of 165 165 puts us over here. We use the original to figure out if we're going to be a positive or a negative answer. Well, in the second quadrant, the only thing that's positive is sign. So instead of saying plus or minus here, we're just going to be using the positive. Cosine in the second quadrant would be negative, and tangent in the second quadrant would be negative. So that's how that works. And that's how we determine if it's positive or negative as we look at the original angle. Now the formula for sine would be 1 minus the cosine of 330 over 2. Cosine formula would be 1 plus the cosine of 330 over 2. And then the tangent formula is 1 minus the cosine over 1 plus the cosine of 330. Okay, well, in order to figure out the cosine of 330, we have to draw that out. 330 puts us right here, where the reference angle is 30 degrees. We have -1, 2, and root 3. So now what we're going to be doing is, let's find the cosine of 330 to figure out the inside part of the radical. It's a little confusing. You use the original to figure out if the answer is positive or negative, but you use the 330 to actually plug into the formula. So I hope that makes sense. If it doesn't, just leave me a comment. But let's figure out what this is. So this is going to be a positive square root of 1 minus the cosine of 330. Cosine would be root 3 over 2. And we're dividing the whole thing by 2. So at this point, one thing that we could do to clean things up a little bit is multiply the top and bottom by 2 inside the radical. We're really just multiplying by a fancy form of 1. What this will give us is 2 minus the square root of 3 over 4 inside of a square root. So we take the square root of the top and bottom. And this just turns into the square root of 2 minus root 3 over 2. That would be the final answer for the sine part. Now for the cosine, it's going to be a negative answer. Square root of 1 plus the cosine over 2. To get rid of this radical, we can multiply top and bottom by 2 over 2. Or it's really square root of 2 over square root of 2. But inside the radical, we're going to be multiplying by 2 over 2. This gives us a negative square root of 2 plus root 3 all over the square root of 4, which gives us a final answer for the cosine of negative square root of 2 plus root 3 all over 2. And then our final problem over here would be a negative square root of 1 plus root 3 over 2 divided by, it's 1 minus root 3 over 2 divided by 1 plus root 3 over 2. So this one takes a little bit more of finesse. Let's multiply top and bottom by 2 to get rid of the fractions. And then let's multiply the top and bottom by the conjugate to get rid of, let's see here, to get rid of the radical in the denominator. Conjugate would be 2 minus root 3. And if you clean things up, it's not the prettiest thing for tangent. Maybe it would have been a little bit easier if we used one of the other formulas, but either way, you'll wind up with negative the square root of, let's see, 4 plus 3 is 7 minus 4 root 3, all divided by the square root of 4 minus 3 is 1. So really, the final answer for a tangent would be negative square root of 7 minus 4 root 3. That would be an answer here. All right. I'm looking at the notes, and it looks like another option that you could have gotten. This is the same number as negative 2 plus the square root of 3. That would be if you use another answer, or another one of the three formulas, you'd get the same thing. Of course, when I'm doing these, I would look at your work and just make sure that they are the same. I'm just going to type it into my calculator just to confirm here. So negative 2 plus the square root of 3 comes out to be negative 0.26, and negative square root of 7 minus 4 square root of 3 is negative 0.26. So they are the same numbers, just depending on which formula you use, they are exactly the same thing. Okay, and I had one last thing for us to talk about today. So we're going to be finding the exact value of the sine of u over 2, cosine of u over 2, and tangent of u over 2 if u is in the third quadrant between pi and 3 pi over 2, and the cotangent of u is equal to 7. So first thing let's do is let's set it up just like we did the last problem. Cotangent of u, we're in quadrant 3. And it says the cotangent of u would be 7. So what that means is going to be 7 and 1. Anytime we go left or down, it's negative. And if we do the Pythagorean theorem, uh, 49 plus 1 is 50. That's 2 and 25. And we get 5 root 2. Okay, so let's figure out what each of these would be. We're going to find the sine of u over 2, the cosine of u over 2, and the tangent of u over 2. Now, in order to figure out if these are positive or negative, let's think about what this angle would be. It's a little bit tricky. So we're in the third quadrant. I'm going to pick any angle in the third quadrant. Let's say 200 degrees. I'm just going to make up a number for you. 200 degrees would put us in the third quadrant. If we take half of that, half of 200 is 100. That puts us in quadrant 2. All right. So what I did is I said pretend u is any number in quadrant 2, like 200 degrees. We're trying to figure out what's the sine of that angle divided by 2, right? So if u is 200 degrees, this angle is 200 degrees, the sine of u divided by 2, we'd be figuring out if it's positive or negative, and that would put us in quadrant 2. The only thing positive in quadrant 2 is sine. So when we go to write our answer for these, that's going to tell us that we need to make sine positive, cosine's negative, and tangent would also be negative. So that's the first consideration, is what quadrant is u divided by 2 in. So now that we know that, let's use the formulas. So sine of u over 2 would be the square root of 1 minus the cosine of u divided by 2. Cosine would be square root of 1 plus the cosine of u divided by 2. And I'm going to use one of the other formulas for tangent. Tangent we don't need to worry about the plus or minus if we use one of the other formulas. So we could use 1 minus cosine over 1 plus the cosine like we did before and make sure it's negative. But I'm just going to show you another way to do it. So let's maybe try using this formula. 1 minus the cosine of x, or cosine of u, divided by sine of u. If you want to use another formula, we should get the same answer numerically. As we saw in the last problem, it might come out to a funky square root answer, but you could convert it to a decimal to see that it's the same thing. Okay, so now let's do the algebra. This is going to be the square root of 1 minus the cosine of u. All right, so the cosine of u would be negative 7 over 5 root 2, which, if we rationalize that, it's negative 7 root 2 over 10. So I'm going to say 1 minus. Sorry, guys, I had some Oreos before, and it must have dried out my throat. So 1 minus the cosine of u would be negative 7 root 2 over 10, and divide the whole thing by 2. Now, what we want to do is we want to try to make this denominator a square root of a perfect number, while also getting rid of the 10. So this is where it could get a little bit tricky. I'm trying to think, what can I make 2 into a perfect square root while also getting rid of 10? If I can make the 2 into 100, that would get rid of the square root in the denominator, so I'd be taking the square root of 100. And if I also multiplied the top by a certain number to get rid of the fractions, it would make my arithmetic easier. And it takes a little bit of practice to do this, but if we multiply by 50 over 50, what this is going to give us on top is it's going to give us 50 plus, it's going to be 35 root 2 all over the square root of 100, which reduces to just be the square root of 50 plus 35 root 2 all over 10. And that's a totally acceptable answer to me. I know it's kind of ugly looking, but there's no fractions inside of fractions, and there's no radical in the denominator. So it takes a little bit of, kind of figuring out to come up with the 50. That might be the hardest part of this problem. Again, we want to figure out what can we multiply to make the denominator into a perfect radical, while also getting rid of all the fractions in the numerator. Let's do the second one. We're going to have 1 plus the cosine, all divided by 2 inside the square root. Again, if we convert the 2, if we multiply 2 by a number to get a perfect square root, like we can make 2 into 4, but if we multiply by 2 over 2, it's not going to get rid of the denominator here. We can make 2 into 36 by multiplying by 18 over 18. That's not going to get rid of the denominator. If we multiply 2 by 10, we're not going to have a perfect square root in the denominator. So you kind of play this game until you figure out, okay, well, it has to be a multiple of 10, and it also has to make, when you multiply by 2, get a perfect square root. So that's where the 50 over 50 comes from. And if we do that, we would get 50 minus 10 goes into 55 times, so that would be 35 root 2 all over the square root of 100, which is the square root of 50 minus 35 root 2 over 10. And this would have to be negative, remember, because u over 2, which is what we're taking the cosine of, would be a negative answer because it has to be in quadrant 2. And then our final problem, we don't have to worry about plus or minus if we're using this formula. Only if we use the square root formula we have to worry about it, but this would give us a positive or negative based on cosine or sine. So we're going to have 1 minus the cosine of u, which is negative 7 root 2 over 10, divided by the sine of u. I'm thinking of the Ed Sheeran song, Picture of You. I can't remember, but Sine of u would be negative 1 over 5 root 2. The heart of u, I can't remember. If we multiply by root 2 over root 2, if you leave a comment, let me remember the sound of you, the Ed Sheeran song, something with you, I can't remember. We get negative square root of 2 over 10 is what the sign would be. So let's figure this out here. Negative square root of 2 over 10. So let's clean this up. If I multiply top and bottom by 10, that would get rid of all the fractions. This would be 10 plus 7 root 2 over negative root 2. And then to finish this up, if we multiply top and bottom by root 2 over itself, this would be 10 root 2 plus 7 root 4, all divided by negative the square root of 4. We're cleaning this up, it would give us 10 root 2 plus 14 over negative 2. And finally, our answer would be negative 5 root 2 minus 7. So that should be the answer there. For homework, this is what I would like you to do. For homework, if you could please take a look at page 418. I'd like you to do numbers 31 to 49 odd and omit 41. Okay, thank you very much. If you have any questions, you know you to leave a comment or you could email me. Have a nice day.